Now in question number 13, D and E are points on the sides CA and CB respectively of a triangle ABC right at angled at C. Prove that AE square plus BD square is equal to AB square plus DE square. Now triangle ABC is right angled at C and D is point on CA and E is point on BC of a side BC of a triangle. Now we have to prove that AE square plus BD square equal to AB square plus DE square. Now we will find all these four separately by using Pythagoras theorem. Now AE square, to join AE in triangle ACE, angle ACE equal to 90 degree by Pythagoras theorem, we will get AE square equal to AC square plus CE square. Now we have to find out BD square. So BD is the side of right angle triangle DCB. In triangle DCB, angle C is of 90, so BD square will be equal to DC square plus CB square. Similarly, we can find the value of AB square from triangle ACB and DE square by applying Pythagoras theorem in triangle DCE. Now here we have to find AE square plus BD square on the left hand side. So we will add equation first and second to get the value of AE square plus BD square. Now adding first and second, we are getting AE square plus BD square equal to AC square plus CE square plus DC square plus CB square. Now on the right hand side, we need AB square plus DE square. As we know, AB square was equal to AC square plus CB square. So here we will write AC square and CB square plus CB square together, and remaining CE square plus DC square with each other. And that will give us AC square plus CB square was equal to AB square, and DC square plus CE square, DC square plus CE square was equal to DE square from third and fourth. And this is the proof of the question 13. In question number 14, a perpendicular from A on side BC of triangle ABC intersect BC at D such that DB equal to 3CD. We have to prove that 2AB square equal to 2AC square plus BC square. The perpendicular from A on the side BC of a triangle ABC intersect BC at D such that, now it is given to us that AD is perpendicular to BC. Now AD is perpendicular to BC and DB is equal to 3CD. These two things are given to us. We have to prove that 2AB square is equal to 2AC square plus BC square. Now in order to prove this, first of all we will find CD and BD in terms of BC, because here we doesn't need BD and CD. So here DB was equal to 3CD was given to us. Now this is our equation first. Now BD plus CD will be equal to BC. Now from first we can write BD as 3CD. In place of BD we will write it as 3CD plus CD equal to BC from first, and this will be give us 4CD equal to BC, and we can say that CD is equal to BC by 4. Now again from first we can, on putting the value of CD in first, from equation first we can say that DB is equal to 3 CD, and CD was BC by 4, and that will be 3 BC by 4. Now here we have to find the value of AB square, and as we know AB square will be equal to AD square plus BD square. So we will eliminate AD by writing it in terms of AC and DC from triangle ADC. Now in triangle ADC, angle D is of 90 degree. In triangle ADC, angle ADC is of 90 degree. So by Pythagoras theorem, we can say that AD square will be equal to, now here AD square will be equal to AC square minus CD square, or DC square will be equal to AC square minus CD square. And this is our equation 4th. Now in triangle ADB, AB square will be equal to AD square plus BD square. Now this means AB square will be equal to, now here AD square, we have from equation 4th, we can write AD square as AC square minus CD square, and AC square minus CD square plus BD square, and BD was in equation 3rd was equal to 3 BC upon 4. In place of BD we can write 3 BC upon 4 whole square from 3rd and 4th. From 3rd and 4th. Now this will give us AC square minus CD square plus 9 BC square by 16. Now AC square, here in our proof we need AC square and BC square on the right hand side. So AC square will remain same, BC square is again will remain the same, as we need AC square and BC square. Now we will convert the CD square, and as we know from in equation 2nd, CD was equal to BC by 4. So CD square can be written as BC by 4 whole square from equation 2nd plus 9 BC square by 16 from 2nd, and that will give us AC square minus BC square by 16 plus 9 BC square by 16. On multiplying the whole equation by 16, we will get 16 AB square. This was the value of AB square. So 16 AB square will be equal to 16 AC square minus BC square plus 9 BC square. Now this will be 16 AB square equal to 16 AC square plus 8 BC square. Now on dividing all the terms by 8, we will get 2 AB square equal to 2AC square plus BC square, which we had to prove. Now come to question number 15. In an equilateral triangle ABC, D is a point on side BC such that BD equal to 1 upon 3 BC. We have to prove that 9AD square equal to 7AB square. Now, in an equilateral triangle ABC, D is a point on BC such that this BD is 1 upon 3 of BC. Now, it is given to us that triangle ABC is equilateral triangle and BD is equal to 1 by 3 of BC. Now we have to prove that 9AD square is equal to 7AB square. Now for that we will draw a perpendicular from A on BC. Suppose AM is perpendicular to BC. Now first of all, AM is perpendicular to BC and ABC is an equilateral triangle. So we can prove that triangle AMB is congruent to AMC and so BM will be equal to CM. In triangle AMB and triangle AMC, so triangle AMB will be congruent to triangle AMB will be congruent to triangle AMC by RHS, and that will give us BM equal to CM. Now if BM is equal to CM, then BM will be equal to CM will be equal to half of BC. Now DM will be equal to BM minus BD. Here DM will be equal to BM minus BD. Now we are finding DM in terms of BC because in our question we have to find the value of AD square. Now AD square will be equal to AM square plus DM square. Now we neither need AM nor DM, so we will find AM square from triangle AMC and DM by subtracting BD from BM. So this DM will be BM minus BD, and BM was equal to half of BC in our equation first, and BD was given to us as 1 upon 3 BC, and that will give us 3 BC minus 2 BC upon 6, and that will be BC by 6. So DM is BC by 6. Now in triangle AMC, angle AMC is of 90 degree. That means by Pythagoras theorem we can say that AM square will be equal to AC square minus CM square. Now from in triangle AMC, AM square will be equal to AC square minus CM square. Now this AC square remain AC square, and CM square, CM was half of BC, and this can be written as half BC square, and this will give us AC square minus BC square by 4. Now, in triangle AMD, angle AMD is of 90 degree. Now, in triangle AMD, angle AMD is of 90 degree. So from here we can find the value of AD square by Pythagoras theorem, and AD square will be equal to AM square plus DM square. AD square will be equal to AM square plus DM square. Now this can be written as AD square equal to, in equation third we have obtained the value of AM square, and that was AC square minus BC square by 4 plus DM square, and DM in our equation second was BC by 6. BC by 6 square. From second and third equation. Now this will give us AD square equal to AC square minus BC square by 4 plus BC square by 36. Now on multiplying both sides by 36, we will get 36 AD square equal to 36 AC square minus 9 BC square plus BC square, and that will be 36 AD square will be equal to 36 AC square minus 8 BC square, and this can be written as 36 AD square equal to, now in right hand side we need AB, so in place of AC we can write AB minus 8, and BC can also be written in the form of AB, because ABC is an equilateral triangle, and due to which AB will be equal to BC will be equal to AC, as triangle ABC is equilateral triangle. Now this will give us 36 AD square equal to 36 AB square minus 8 AB square will be equal to 28 AB square. On dividing both sides by 4, we will get 9 AD square equal to 7 AB square, which we had to prove. Now in question number 16, in an equilateral triangle, prove that the 3 times the square of one side is equal to 4 times the square of one of its altitudes. Now ABC is an equilateral triangle. Let AD is altitude from A on BC. We have to prove that 3AB square is equal to 4AD square. Now, as we know, triangle ABC is equilateral triangle, so sides AB will be equal to BC, and that will be equal to AC. Now, in triangle ADB and triangle ADC, now triangle ADB and ADC will be concurrent, as angle ADB is equal to angle ADC, and that is equal to 90 degree. AB is equal to AC from first, or these are the sides of equilateral triangle, and AD is equal to AD, that is common side. So we can say that these two triangles ADB and ADC are concurrent by RHS rule of concurrency. So if ADB is concurrent to ADC, then we can say that BD is equal to CD, and that will be half of BC. Now in triangle ADB, angle ADB is of 90 degree. So we can apply Pythagoras theorem in triangle ADB, and from that we will get AB square equal to AD square plus BD square. So here by Pythagoras theorem you can say that AB square will be equal to AD square plus BD square. Now this will be AB square equal to AD square, and BD was half of BC in equation second. In place of BD we can write it as BC upon 2. Now this will be AD square plus BC square by 4. Now on multiplying the whole equation by 4, we'll get 4AB square equal to 4AD square plus BC square, and this will be 4AB square minus BC square equal to 4AD square. 4AB square minus BC, as AB and BC are the sides of equilateral triangles, so BC can be written in terms of AB, and that will be 4AD square. From in first equation we have taken AB equal to BC equal to AC. So from first we can write BC as AB, and this will give us 3AB square equal to 4AD square, which we had to prove. Now in question number 17, here we have to take the correct option in triangle ABC. AB, AC and BC are given to us, and we have to find the angle B. Now two smaller sides in these three sides are AB and BC. So AB square plus BC square will give us 6 root 3 square plus 6 square, and that will be equal to 108 plus 36, and that is equal to 144. Now AC square will be equal to 12 square, and that is also equal to 144. As AB square plus BC square is equal to AC square, so by converse of Pythagoras theorem, we can say that angle ABC is of 90 degree. In question number 12, two poles of height 6 meter and 11 meter stand on the plain ground. If the distance between the feet of the poles is 12 meter, find the distance between their tops. Here, two poles of AB of height 6 meter and CD of 11 meter are 12 meter apart from each other. That means AC will be 12 meter. Now, on drawing the perpendicular from B on CD, this BE will be equal to AC, and that is 12 meter. ED will be equal to CD minus CE, and as we know CE is equal to AB, so we can say that ED will be equal to 11 minus 6, and that will be 5 meter. Now we can apply Pythagoras theorem in DEB, in triangle DEB, to find out the value of BD, and that will be the distance between the top of the poles. Now in question number 11, an aeroplane leaves an airport and flies due north at a speed of 1000 km per hour. At the same time, another aeroplane leaves the same airport and flies due west at a speed of 1200 km per hour. How far apart will the two planes after 1.5 hours? Now, one plane flies due north at a speed of 1000 km per hour and another is flying due west at a speed of 1200 km per hour. Now, in 1.5 hours, distance covered by the plane flying due north is OA, and that will be 1000 into 1.5 speed into time, and this is equal to 1500 km. Similarly, the distance covered by the plane flying due west will be equal to OB, and that will be equal to 1200 into 1.5 hour, and that is equal to 1800 km. Now in we have to find distance between two aeroplanes. So in triangle AOB we can apply Pythagoras theorem to find AB, and that will be equal to 300 root 61 km.